Here is our full test review for test number 8 over linear equations. And I'm just going to jump into question number 1. It says, what is the equation of this line? So the equation of a line is in the form of y equals mx plus b if it is non-proportional, or y equals kx if it is proportional. So in this case, our line does not pass through the origin, so we have a non-proportional line. So we're going to be looking for a line equation that looks like this. This one includes m, which is our slope, and b, which is our y-intercept. So those are the two things we need to find. So I think it's always easiest to start with finding the y-intercept, which is where the line crosses the y-axis. So our b, y-intercept is going to be a positive 2. And then in order to find our m, we're going to find our rise over run. Since it's on a graph, we need a couple more pretty points in order to do that. So I'm going to then use these pretty points I just put on the graph, and I'm going to find my rise, which is 1, and my run, which is 1, 2, 3. But since I moved in the, and then overall, this slope is negative, so we need to make sure that that slope is negative. And overall, we're going to put those two together, and we have an answer of y equals negative 1/3 x plus 2. And that is the slope of this line, or the equation for this line. All right, number 2. Which equation represents the relationship between x and y shown in the table? So in order to find, again, an equation, we're needing to find a slope, which is m, and a y-intercept, which is b. So in order to find slope, we don't have a graph, so we could put this on a graph, but these numbers are really big, and it might just be easier to use our slope formula, which is m equals y2 minus y1 over x2 minus x1. So in order to do that, we need two coordinate pairs, and we can find those from the table. So I'm going to use the two coordinate pairs 0, 1.5, and 136.5. So in order, I'm going to draw the skeleton from my equation, and then I'm going to label my coordinate pairs. So we have x1 and y1, x2, y2. And then we're going to take those numbers and place them where they would go in the equation. So y2 is 36.5, and y1 is 1.5. x2 is 100, and x1 is 0. So from there, we're going to simplify. So 36.5 minus 1.5 will give you 35. 100 minus 0 is 100. So we don't see any of that slope in any of the formulas. So let's go ahead and take that and turn it into a decimal. So 35 divided by 100, we know is going to be 0.35. And then, so that's our slope here. I've just written that in. And then our y-intercept is where our line is going to cross the y-axis. So where x is 0, y is going to be what other number? So we see that in the equation. When x is 0, y is 1.5. So our y-intercept is a positive 1.5. So then we can put that into an equation, those two numbers, and that lands us at answer choice A. Number 3, the table shows the relationship between miles traveled and fuel in a car's tank. Write an equation that represents the data. So in order to write an equation, we're going to need a slope and a y-intercept because we have y equals mx plus b. So I'm going to use a slope formula again because I don't want to put this on a graph. So I'm going to use my slope formula. M equals y2 minus y1 over x2 minus x1. And I'm just going to choose the first two coordinate pairs as my x1, y1. So this is going to be x1, this is going to be y1, this is going to be x2, and this is going to be y2. So I just turned these into coordinate pairs because that's what we can do. And then I'm going to transfer those into my equation. So y2 is 14.6, y1 is 15, x2 is 10, and x1 is 0. So when we simplify that, 14.6 minus 15 is a negative 0.4, and 10 minus 0 is 10. So when we divide that, that leaves us at a negative 0.04 for our slope. So now we can write into our equation negative 0.04x. And then we need to figure out what our y-intercept is. So the y-intercept is where the line is going to cross the y-axis. So I'm just going to sketch this really quick. So if I had 5, 10, 15, 5, 10, 15, if I were going to take this point right here and put it on the graph, it would be located 0, 15 right here. So this first point, this right here, is what the y-intercept is, and that's at a positive 15, so I can put that into my equation right there. Y equals I should probably erase. Okay, y equals negative 0.4x plus 15. Okay, number 4. Determine if each graph shows a proportional relationship. Explain why or why not. So, in order for a relationship to be proportional, it has to be a straight line and it has to go through the origin. So, this line is a no, and this line is a yes, and this is because no, because it doesn't pass through the origin. And yes, just the exact, because it does pass through the origin. Okay, number 5. Mr. Bagford is ordering rope for his boat. The rope costs $3.75 per foot. The shipping is $20. Write a function that can be used to find y, the total amount Mr. Bagford would pay for X feet of rope. So this is where we want to talk about constants and variables. So variables, we're going to be using, this will have the x's with it, and the constants are just going to be normal numbers. So if you think about the amount of rope he's buying, this is going to vary per foot. So this is going to be a variable. So when he pays $3.75, he's not just going to pay that one time, but we're wondering how many feet he will choose. And then, unfortunately, he has to pay for shipping. And that shipping is going to be a constant number of $20 per. All right. Number 6, determine if each of the following represents y as a function of x. If not, explain why. So this first one, we're going to be looking at our inputs. So we have input of 5, 3, 4, and 2. So all of our inputs are different, so we are in the clear for it being a function. The second one, we have inputs of 4, -3, 4. Okay, so that's suspicious. Okay, so if I have this 4, it's saying if the input is 4, it should be 1. But the next time you used a 4, the input was 5. So unless this output here was the same, like if this said 4, 1, that's the only way it would be okay to repeat that 4. But in this case, it's not, and that is why. So no, because of a repeated input with not a repeated output. Okay. Let's look at this one. So we have our x values and our y values. So here we have an input of 7 to -21, 9 to -3, 11 to 121, and 45 to 15. So we have all different inputs and related to one output. So we have a yes here. This next one here, we have a 2 that is an input and an output of 5. And then we have a 2 with a different output of 20. So this is where we have to ask ourselves, okay, is this a function or not? And because 2 has 2 different outputs, we can say it's not. No, because the input 2 has more than one output. Okay? All right, and then when we're looking at graphs, we can use the vertical line test. So let's take our vertical line test and see what we come up with. So I'm going to take this vertical line. We're going to see if it passes. So this one, it passes all the way across the board. So this one is going to be a yes, it's a function. The next one, we see our circle. So when we pause here, as we're moving across the circle, we see that the vertical line touches the graph twice, which is a no to a function because of failing the vertical line test. All right, and the last one we have right here. So we have, again, it would fail. So I'm going to just say same answer as before. No, because it fails the vertical line test. Number 7, what is the slope of line ST? And we'll stop there. So we have our triangle here that is plotted on the coordinate grid. And we're asked to find the slope of line ST. So line ST is from here to here. So what we can do to find the slope is find the rise over run. So since this graph isn't super great, what I'm going to do is use this slope triangle so I can see from this pretty point down here, my rise is going to be 1, 2, 3, 4, 5. So that's my rise. And the run is going to be 1, 2, 3, 4, 5, 6. The run is going to be 6. And we're going in the left direction, so that's going to be a negative. Or, again, as long as the overall slope is negative, so that's going to simplify to -5/6. The next question is dealing with the same picture, but a different question. It's saying, what is the length of ST? So we found the length when we counted the rise over run, we found the length of each side of the triangle. And since it's a triangle, specifically a right triangle, we can find the length of the other side. So if this is ST, we can find this by using the Pythagorean theorem. So what we're going to do is a squared plus b squared equals c squared. So a is going to be 5 squared plus 6 squared equals c squared. So this has, so this is going to be 25 plus 36 equals c squared. So that gives us 61 equals c squared. And then in order to find just c, because that's the length of the hypotenuse, we're going to have to take the square root of both sides and get c equals square root of 61, which is 7.81. So that is the length of ST. 7.81. All right, the next one says solve the equations and show all your work. So here we go. So I'm going to draw a line down my equation. I'm going to box my variable, circle my constant, box my variable, circle my constant, and then I'm going to ask myself those 4 questions when solving equations. So first is if there are any like terms, and there's no like terms on the left or the right. So then we're going to move to moving our least variable, which is our least coefficient, which is 6. So over here, that becomes 0. And on the left side, we're left with 2 equals 9 minus 6 simplified is 2. 3x minus 7. And then our third question is, are there constant numbers? And there are. So we're going to move the constant number that's on the same side as the variable to the other side by inverse operations. Then simplify. And then our last step is to divide by our coefficient. And that leaves us with x equals 3. All right. Next question. We have our boxing our variables, circling our constants, boxing our variables, circling our constants. And if you notice, I'm including the signs before so that I don't forget the sign, so I don't miss add or subtract. And since there are no like terms on the left or the right, we're going to go ahead and find our least variable, which is the least coefficient, which is 8x. I'm going to subtract 8x from both sides and then simplify. 5 equals 12x minus 8x is 4x minus 25. And then since we have constant numbers on both sides, we're going to add 25 to both sides. And then we're left with 4x equals 30. And then divide by our coefficient of 4, and we're left with x equals 30 divided by 4, which is 7.5. All right. Number 10 says a fish tank is being filled with water as shown in the graph. Our question is, after 8 minutes, how deep will the water be? So this, we could go to 8. After 8 minutes, how will the water be? So it's where it crosses. So it looks like at 8 minutes, the water is going to be 24 centimeters deep. So now we're asked to find the slope of this line. So in order to find the slope, we need some pretty points on the graph. And I know that the graph crosses through at the y-axis there. And so what we could do, we could use the slope formula. We could find the coordinate pair, but it might be easier to just do the rise over run. So from the y-axis, I'm going to count up here. And if I notice, when I want to say 1 right there, I have to notice that this right here says 8. So that means that this is 4. So the interval on this graph is going by 4s. So when I count up one space, it's actually 4. So I'm going to go 4, 8, 12, 16, and 20. So my rise is going to be 20. And then my run, it looks like I'm moving one space here. And I need to just check my interval down at the bottom. And it does look like it's going by 1, 2, 3. So we're good on that one. So let's count 1, 2, 3, 4, 5, 6, 7, 8. So 20 over 8, which will simplify. We could divide both of these by 4. So when we divide 20 by 4, we get 5. And we divide 8 by 4, we get 2. And that is the simplest version. You could also put it in a decimal. But again, it's easiest if it's in rise over run format. And then we have our y-intercept where it crosses the y-axis, which is at a positive 4. So putting those together, we have y equals 5 over 2 x plus 4. And if you write 2.5 x plus 4, you technically would not be wrong. So in this problem, what does the slope in the context of this problem mean? So thinking about if the slope in relation to the change in y, which is the water level, to the change in x, time, we're trying to see how much time it takes, how quickly the water level rises, or how slowly the water level rises. So something along those lines. And what does the y-intercept means in the context of the problem? It's where the water level began. Okay. All right. 2 customers took out loans from a bank. Autumn took a 4 out of 4 year loan for $4,000 and paid 3.8% annual simple interest. Summer took out a 6-year loan for $4,000 and paid 3.2% interest. What is the difference between the amounts of interest and Autumn and Summer paid for their loans? So I'm going to just set up an Autumn side and a Summer side. So what we're going to be doing is looking at simple interest in both cases. So our formula is going to be I equals PRT in both cases. So with Autumn, when we substitute, we know our principal amount is $4,000. The rate is going to be 3.8, but we have to divide that by 100, which would take us to 0.038. And then our time for Autumn is 4 years. For Summer, we get a principal amount of also $4,000. But her rate is 3.2, which will be divided by 100, so 0.032, and a time of 6 years. So that's the difference. So then in your calculator, you can type those out. So 4,000 times 0.038 times 4. This gives you an interest for Autumn at 608. And for Summer, we get 4,000 times 0.032 times 6 with 768. So they're asking for the difference between Autumn and Summer. So we're going to take the 768 from Summer and the 608 from Autumn and divide. Or sorry, not divide, subtract. So that would give us $160 difference in interest that both of them earned. Or sorry, I guess paid, not earned. All right, the table shows the amount of water flowing over in flowing over a dam. So in time and volume, and we're being asked if the relationship is proportional or not. So in order to tell if it's proportional or not, we have to take well, there's multiple ways we can figure out if it's proportional. It's if each of our time and volume increases at the same rate. So what I like to do is take the y and divide it by x, because that's going to be able to tell me what k would be, or the constant of proportionality, if I do have to write an equation. So I'm going to take each of my y's and divide them by x and see if I get the same answer all the way across the board. So 4 divided by 3 is 1.3 repeating. And let's see if 8 divided by 6 is the same thing. So this is also 1.3 repeating, so we have those two. And then 12 divided by 9 is also 1.3 repeating, so those are also equal. Then we do 16 divided by 12, which is also 1.3 repeating, so those are equal. And let's see if this last one messes it up. 20 divided by 15, also 1.3 repeating. And so each of these is proportional to one another, so we can say yes, and our justification is right there, that they all produce the same growth. And then we're asked for the unit rate, and the thing is, we just found the unit rate all the way across the board, because unit rate is another word for slope. So we can say 1.3 repeating is the cubic feet per second. And it could also, or it would be 4 over 3. So whichever one worked, 4 over 3 or 1.3 repeating. All right. Number 13, the graph and table show a linear relationship. Write a linear equation to represent this situation. So you could go about doing this multiple ways. You could use the slope formula and you could use the slope formula. So if you choose to do that, you could be x1, y1, x2, and y2. Or you could do a rise over run on the graph. So I'm going to do both. So if I were to do the slope formula, I would do 40 minus 65 over 6 minus 1. So 40 minus 65 is negative 25, and then 6 minus 1 is 5. So my slope here from the formula is a negative 5. So that is what from the formula. But if I'm looking at it on a graph, I could do my rise over run and see if I get the same answer. So I'm going to use pretty points. I could essentially put in a line there where I just highlighted. So I'm going to take my pretty point. I'll use a different color. So if I take my pretty point let me use maybe blue. If I take the pretty point here and here, because you can use any of them, remember they would all simplify to the same thing. So I'm going to choose these two at the top. So my rise, actually it might be kind of hard to do from there to there, so I'm going to choose this one. So I'm going to choose my rise here. It looks like I'm only moving 1, but I have to look at the interval on the y-axis, and the rise is actually 10. And the run, it looks like I'm going over 1, 2, but I need to make sure at the bottom, okay, that's still 2, so I can put 10 over 2, and then moving in the negative direction, so this also is negative 5. So either way you do it, you'll end up with the same slope, and then you'll have to look at the graph to figure out what the y-intercept is. So what we can see here is that the y-intercept is going to be b equals 70. So now we're going to take our slope and our y-intercept and put them into an equation. All right. And the last one was the new information that we did today, if you were in class. And today as in March 9th. And we learned that when you take two equations and they come together to form a system, the system has to find a solution, and the solution is where the two lines cross. So we can see here that these two lines intersect right here. So we can see that this line and this line is where they intersect. So that would be a 5 over 5. So we need a location, 5, comma, -2. And that is the solution to that system. And that is the end of the review.